Good morning, everyone, and much more important than all that stuff is the fact that I'm renewing my acquaintance with the PWI. Because when I joined BR in 1979 in South Wales, one of the first things I was suggested I do was to join the PWI, which I did, and my membership lapsed, and I've sort of tried to renew it once or twice, never quite got it, but I'm going to, and I'm immensely proud to be wearing the badge that Stephen presented with me last night. So really good to be here, folks, really good. Before I get into talking about the main content about decarbonisation, I just wanted to say a few words about where we find ourselves. Because temporarily, at least, or hopefully temporarily, decarbonisation is not the biggest challenge the world faces, quite obviously, given what's going on in Ukraine. And I was called out at the meeting this morning to talk to friends in Poland who are basically putting aside a house for Ukrainian refugees and feeding them for 6 months. And the response by European railways has been fantastic. There's 100,000 people a day being brought out of Ukraine by rail. 600 pallets of food every night are going into Kyiv. Every single night. 600 pallets of food and other essential supplies. And it just happened like that, within about 3 days of the crisis coming on. Now, there are two messages I guess I'd like to take from that. One is the moral thing, that how good it is that people are stepping up and doing those sorts of things. But the other one, and this might be a little controversial, and Peter Dearden has told me I've got to be controversial, it says something about agility. And we heard before the break about how we are less agile now than we've ever been, and I would certainly support that. And for what's happening in Ukraine and surrounding countries, just says to me that when the need is there, when the desire is there, people can be agile. You can do things, you can make things happen quickly without getting bogged down in process. And I think it's an important lesson there for all of us. Process is to a degree necessary, but fundamentally there are things which are more important. And I'm sure we've all seen some of those wonderful pictures from the Second World War with a massive bomb crater on the approach to Cannon Street or somewhere like that. And the railway was running again in 12 hours. Now, my challenge to you as engineers is, go and do that. Adopt that mentality. Don't be unsafe, but adopt that can-do mentality, because we need that in terms of both Ukrainian crisis, and we certainly need it in terms of decarbonisation as well. So there we go. Let's get on to the slide. So, a little bit of background first about freight. When coal-fired generation of electricity ceased, or effectively ceased when it was announced, a lot of people thought, that's the end of rail freight. Actually, no, because the last 2 quarters, quarter 1, quarter 2 this financial year, we've seen the highest level of non-coal rail freight on record. And the data goes back to 1982, so that's at least 40 years, and we can extrapolate backwards to about the 1960s, so we can say almost certainly we've got the highest level of rail freight in 60 years. Now that's something worth clinging on to, because that's damn good news. The coal loss was close, nothing to do with rail's competitiveness. It was government energy policy. So we can't sort of grieve too much about that. Just move on, it's happened. The focus is now very much on where else we grow the railway. And the key one is consumer goods. Probably comes as a surprise to you to learn that consumer goods are now the biggest single sector that we serve in UK rail freight. So this industry was based on bulk materials, coal and steel and all that sort of stuff. No, the biggest single commodity is supermarket goods, consumer goods, the sort of stuff that you buy yourselves in Tesco and Homebase and all sorts of places, Screwfix, lots of places like that. That's the biggest single move that we make in the UK, say 40%. Mostly deep sea on the import side, but also some really significant opportunities in terms of short sea, coming across the North Sea, and particularly on domestic trunking between distribution centres in the UK. The other big growth area is construction materials, mostly aggregates, some cement as well, where that's about 30% of total rail freight in the UK, but growing unbelievably quickly. It's gone off the graph this year. Quarter 3 is going to be quite remarkable, but it's right across the piece, and it's partly to do with major projects like HS2, and it's partly to do with bread and butter type traffic, but it is quite remarkable how quickly construction is growing. And the rest of the business, the bulks, steel and biomass, waste and things like that, all good, and we've also got some potential in things like automotive and timber, but I won't dwell too much on that. What are the drivers of this rail growth? Well, decarbonisation, pure and simple, that's the strategic driver. That if you went back 2, 3, 4 years, most companies had in their corporate social responsibility statement some woolly fine words about decarbonisation. Now they mean it. Now they really do mean it, and we are seeing that almost on a daily basis. And it's largely because, as we saw in one of the graphs this morning, most other things have been addressed, and transport remains one of the biggest and most intractable challenges they face in decarbonising their supply chain. You know, it's recyclable packaging, cosmetics not tested on animals, all those good things have been done. The really intractable thing is this. So we now have not only supermarkets, but now major brand food and drink manufacturers switching to rail big time. So I don't think I can quite yet tell you the name, but a major, very, very well-known soft drinks manufacturer is now sending 2 train loads a day of their product from the production plant in Yorkshire, one to Scotland, one to London. Things are changing before our very eyes. It's quite remarkable. So the decarbonisation imperative is what underlies it, but it's been turbocharged by the HGV driver shortage, which was the final straw was Brexit, where the Poles and the Hungarians and the Slovaks went home because we basically told them we didn't want them, didn't we? But it's been building for many years because one of the main sources of drivers, HGV drivers, was out of the army, which William, I'm sure, will recognise, where not only from RCT or Royal Corps Logistics, but most other regiments, well, lots of guys trained as truck drivers, so they would come out and just walk into the road haulage industry. Because the size of the army is now so much smaller, that supply has dried up. And not only is it a matter of numbers, it's a matter of what people are prepared to do. Because clearly the army life encourages and requires people to be flexible and rough it a bit. And that's exactly what road haul is needed for long distance overnight trunking, where living, eating and sleeping in a cab for days on end. But the army is about the only other organisation in the UK that requires its employees to do that. For everybody else, that's completely unacceptable. And that realisation is now dawning that, yes, it's fine to drive a truck if you can come in the morning, do a day's work, come back in the evening, go home, see your family or your mates, go down the pub. Absolutely fine. But the younger generation won't do that tramping, as it's called, long distance and sleeping in the cab. That is a very important driver for the growth of rail freight. So we have this new model of logistics starting to emerge, which is, as in bold halfway down that slide, trunk by electric rail and distribute by battery or possibly hydrogen truck. Great news, just at the end of last year, we now have in service 37-ton pure battery HGVs. And even better, they've been used on a rail-linked supply chain. They're moving swap bodies from Wentloog into Modal Terminal to the Tesco DC distribution centre at Mega. 37-ton gross, that's about sort of 22-ton payload with a range of 100 miles. Now, that just prompted me to have a look at how much of UK road haulage that caters for. And the answer is quite remarkable. 61% of HGV tons lifted in the UK can already be moved by battery HGV on the basis of the trucks that we have today. If we could get it up a little bit, and with the rapid development of batteries and charging technology, I think that's a very reasonable assumption, we can very quickly get that to about 74-75%. So basically everything under about 150 kilometres, something of that distance. Great news. That means that the local and regional distribution, we've basically cracked it. But, and here's where rail comes in, there is no solution in prospect for long distance trucking. Diesel fuel is an unbelievably energy efficient fuel. You know, the energy you get into a space and a small unit weight with fuel oil is way greater than anything else. So, the prospect of a battery long distance truck is extremely remote. There's something called ERS, Electric Road System, which has been trialled in Sweden and in Germany. It's claimed to be an extension of railway technology. It isn't actually. It's an extension of trolleybus technology, because of course there's no steel rail for the return current. So it's a trolleybus-based system. Nevertheless, it does work technically, and that's the point. Because the problems aren't technical, as we know all too well from the railway. It's the operational aspects of an electrified railway that catch us out, not the technical ones. And at the moment, it's the advocates are very much in that technical space, and it's don't want to listen to the operational reality. So there's an interesting debate going on there. Hydrogen, it has its place in a few places in the economy, in a few places in transport, particularly where you have byproduct hydrogen in places like Teesside and Merseyside for the local bus system, the local dust carts and that sort of thing. But producing green hydrogen is incredibly expensive and inefficient. So if you take a unit of electricity coming out of a solar farm or a wind farm, producing hydrogen takes 3 times as much power as using the electricity direct. So if you want to pay 3 times as much for your fuel, that's kind. You carry on going down that road. For everybody else, I suggest that using it as electricity, either by container or battery or something like that, is probably going to be a much, much better route. So all this points to the fact that the trunking aspect, over about 200 kilometres, rail is in a very, very strong position. And this was recognised by the Transport Decarbonisation Plan. Indeed, it's the only proven option for long-distance trunking that we have in the UK. Now, the good news is that if you take the core freight net, which is about 2,000 route miles, 2/3 of that is already electrified, combination of overhead and third rail. So we only need about 750 to 800 route miles to take about 95% of freight electric capable. So TDNS, the full program, is fantastic. Was it 13,500 SDKs, something of that order? We only need about 2.5 for freight. And in terms of the importance and the urgency of saving carbon quickly, our contention would be that those freight routes, which of course also benefit regional passenger and other things, they should be the priority within TDNS. On we go. So what's the scope for modal shift? It's all well saying we can do it, but how much of it can we take? What are the implications? So the general perception, especially in the logistics industry, is that the scope is limited, very limited, most people would say to you. So a year or so back now, I decided to try and draw some data and do some analysis of the data. So the data source is the DFT stats, bit of a mouthful again, the CSRGT, Continuing Survey of Road Goods Transport. But it's actually quite good data, because it's by commodity, by distance band, to a degree by route in terms of interregional and inter-sub-regional. It's not perfect, it's based on a sample, but it's the best we've got. So I pulled that apart to see what we could do of that current road haulage movement, based on, and this is important, what we already do in terms of size of train, speed, commodity, all that sort of thing. So that basically means we do non-bulk freight, the consumer stuff, over about 200 kilometres, and we do bulk freight, like aggregates and steel and such like, over about 100 kilometres. Actually quite a bit less, but err on the safe side and take 100 kilometres. Staggeringly, 53% of all, not just long distance, but all HGV ton kilometres are in those bands. So forget the idea that rail is an irrelevance today. Over half of HGV ton kilometres are at least broadly suitable for rail, modal shift to rail. Now, not all of those trips will be. There are a whole host of reasons why it wouldn't happen, at least not in any time soon. And it's a lot to do with critical mass, density of traffic, remote rural areas will be tricky. Some destinations will have particular issues. But the key point here is that most HGV moves are concentrated on the key motorway axes. No surprise, you see it as you drive around the country. They are not in the remote rural areas. The big volumes, the big numbers are on the motorway routes, where, of course, we have, in almost every case, a parallel railway route. There are very few commodities which can't be moved by rail. So on a daily basis, we now move frozen and chilled and fresh produce. Tesco launched a train back end of last year, daily train, Tilbury to Scotland, with all the fresh and chilled produce they sell in the Scottish stores. Amazing, right? And it's refrigerated swap bodies. That's the technique. It's not handballing stuff out of railway vans. It's swap bodies that are simply lifted from the train onto a truck. There are a few things we probably wouldn't want to take, like livestock or civil engineering plants. So, there are very few things. I'm not saying everything, but the vast majority of stuff we can get into a swap body. One of the issues is that it will have to be a sort of multi-customer operation. Tesco and one or two of the big manufacturers have enough volume for their own trains, but in most cases, it's going to be a multi-customer operation, an aggregation of various customers. We already do it on the Anglo-Scottish route between Daventry and Scotland. We have around about 12 trains a day on that route, and overall the Anglo-Scottish rail movement is now 28 trains a day. That's about 1,000 HGVs a day taken off the M6 and the M74 already today, so we definitely can do it. And there are some companies like Russells and Malcolms and PD Ports who are actually offering these aggregated services, and that's probably the model to go forward. Take all that together and we come to something over a third of all HGV ton kilometres, 38% is the number, but don't worry too much about the specifics, and about 15% of HGV tons are highly suited for modal switch to rail. What are they? What are those flows? So it's basically everything over 300 kilometres. It's deep sea and short sea boxes and automotive to and from the ports, 200 to 300 kilometre band. Some of the domestic trunking in the 200 to 300 band. And this is particularly between national distribution centres and regional distribution centres. Some of the heavy bulks, particularly aggregates and metals, in the 100 to 300, and then other bulks like chemicals and one or two other things in the 200 and 300. So those are the sort of specifics. What that gives us is a potential of about an extra 200 million tonnes a year of rail freight. That's a trebling, effectively. Well, actually, it's a quadrupling, actually, because we're now at about 70 million tonnes in the UK per annum. We were at 100 pre the coal decline. This would take us to around about 300 million tonnes a year. So it's big growth, at which point people in Network Rail access plan are thinking, oh, can we incorporate it? The obvious threat or worry, rail couldn't cope with the modal transfer. Well, perhaps it can. Because the key point to bear in mind here is that every single train we run moves between 50 and 80 lorry loads on one train. So on the consumer goods side, it's about 50. On the bulk side, it's about 80. And that, by the way, is on existing best practice. There's no super trains or jumbos or anything like that. When we're into the jumbo trains, we're up to about 125, 130 trucks in each train. So we can convert that 200 million tonnes into paths. And we do it on the basis on the screen now. So a bulk operation will be 2,000 tonnes one way, but almost always going back empty to the loading point. You don't take anything back to a quarry by the nature of the beast. Domestic trunking is about 1,000 tonnes per payload tonnes per train, but it's loaded both ways because you have to do that to make it pay. Deep sea and short sea, on the other hand, because of the balance of trade, is 1,000 tonnes for the whole round trip, and it breaks down to about 750 import, 250 export. Actually, in reality, it's probably nearer 800, 200, or even more, because we produce and export so little in this country these days. So we can then take 18 hours per day. Now, we chose 18 on the basis that we would assume that the morning and evening peaks continue. That 3 hours in the morning, 3 hours in the evening, we basically wouldn't have access to the network. We don't accept that, I'm not advocating it, but as an analytical assumption, that's the basis we took. That then brings you to 26 trains per hour across the network, 18 hours a day. And that then breaks down to only 1 or 2 additional freight trains per hour on most main routes. Now, I'm not suggesting that's falling off a log, but I am suggesting we jolly well ought to be able to encompass that on a lot of lines. The exceptions, so therefore the challenges to that, are 2 routes, the West Coast Main Line and Felixstowe to Nuneaton, where 3 to 4 extra trains per hour would be required. It's essentially 3 peaking at 4 on certain sections, so particularly on the West Coast Main Line between Bletchley and Nuneaton, broadly, where you've got lots of flows converging before they start splitting off again. And the same with Felixstowe to Nuneaton, where a certain section, particularly Peterborough to Ely, you have all the flows concentrated on that one section. Across London is quite interesting, at about 3 trains an hour as well, but that's fairly short distance, so we don't need to worry too much about that. What do we need to do about it? Well, across London, start that one first. There's some really good work done by Network Rail and the rest of us in freight over the last year or so. Produced a London rail freight strategy, which is completely compatible with TfL's aspirations and the Mayor's aspirations for increased passenger services on North London Line and West London Line routes like that. West Coast South, HS2 should give us the solution. It does hinge on where that extra capacity is allocated, but there doesn't appear to be too much of a challenge to incorporate that amount of extra freight on the West Coast South. Felixstowe to Nuneaton, F2 M&N is the new moniker. Felixstowe to Midlands and North, that's the new brand name for it. There's a really well-defined package of work required to get to that extra capacity. And it's pretty simple, actually. I mean, it's doubling some more of the Felixstowe branch, and it's doubling the 4.5-mile single-track section between Soham and Ely, which I would point out to you is akin to having the A14 with one lane for all traffic in both directions. I don't think that would be terribly tenable. So we really do need to crack on and do that, and Peter and one or two others of us are in discussion with funders on that. I regard West Coast North as probably the biggest challenge, where we will have more passenger trains coming off HS2 at either Wigan or Preston, depending on where Sir Peter Hendy decides he wants to go with that, and more freight as well. Personally, I don't think we need to be building lots of new lines around the back of Lancaster from Abington down to central Scotland. I think the cost and the environmental impact of that would be unacceptable. So we need to look at it in a creative operating manner. And that comes down to, how do we get the best out of a two-track railway? And almost always the answer to that is flight your trains. So if you take a half-hour, repeating half-hour pattern, first train up on 00 past the hour, a flyer, an Anglo-Scottish flyer off HS2. That goes on first. 2 or 3 minutes later, what you might call a stopping class 1 that's going to do Lancaster, Oxton, Hove, Penrith and stock jobs like that. 2 or 3 minutes after that, a class 4, 75-mile freight train, and possibly a second one running in close proximity. And if there are any class 2s, Barrow, Windermere and places like that, they can follow the freights. Now, if you map that onto the West Coast Main Line, what it gives you in general terms, and I'm not claiming this is a precise solution, but generally speaking, if you can have dynamic loops in the sort of Carnforth-Oxenholme area and in the Lockerbie to Beatock area, the passenger trains in the next flight can overtake the freight trains in the previous flight. So what we're talking about, in other words, is strips of land alongside the existing railway. You know, basically 10-metre wide strip built behind a blue fence alongside the existing railway. And for debate whether we have 2 parallel loops of about 2 kilometres long each, or whether we have one longer loop at about 5 kilometres each, because we need to accommodate 2 long freight trains at the same time. But that is doable, and there's some good work starting to be done now by the strategic planners for North West and Central North, which we're heavily engaged with that. So it's doable, but we need to be sort of working on this. And of course, we also need to be electrifying. As Peter and I are spending quite a bit of time on this as well, about getting the costs down, because it's too expensive, folks. Way, way too expensive. You know, GWEP at, was it £2.3 million per single track kilometre? That's obscene, frankly obscene. Where we are today at about £1 million, aspiring to £1 million per single track kilometre, that is also way, way too high. What we need to be doing is getting it down to probably about £500,000 for the catenary and the power supply, and obviously on top of that you have structures on a route-specific basis. But I would point out that in the flatlands of East England, like Felixstowe and the joint line up through Lincoln, there aren't many structures. There are very few bridges, so there ain't much to put on top of the £500,000 per single track kilometre. We've got to do that, and we need to spec it properly, because most of these routes, we don't need 125-mile capability. We need 75-mile capability for freight and regional passenger services. I am no engineer, I can guarantee you that, but I do sort of think that means probably masts at wider spacings and perhaps less robust wiring and things like that. So there's specking issues to be done there as well. Finally, terminals. If you have an intermodal supply chain, you have to have terminals. They're the nub of it all. This is where it all happens. Some very good stuff happening. In what's called the Golden Triangle Logistics in the East Midlands, we have a whole host of SRFIs, as they're called, Strategic Rail Freight Interchanges. Daventry was the biggest and longest standing one. That's now about to be trebled in size in terms of its handling capability. But we have several more coming through. We have Northampton Gateway coming through. Hinckley is going through the planning process. The developers, the commercial property developers and their customers have long since realised that rail connection for national distribution centres is pretty much essential. So lots of good stuff happening in the Golden Triangle. The next stage of the supply chain to the regional distribution centres, more to do. So obviously the NDCs in the centre will have the rail connection in a lot of cases, but the RDCs around the country often don't. And RDCs cluster. because basically all retailers all serve the same population, and therefore the optimal location for the RDC is more or less in the same place for all of them. So we need to address some of these clusters which are not well served. So the northwest is a really important one. Haydock and Wigan is where the RDCs cluster for the northwest. Parkside is coming. Parkside has got its first phase DCO, and that's good. We need to move on with that. But we need another one in the northwest, probably Port Warrington. And the same applies in Avonmouth. Generally speaking, rail freight isn't much into the last stage of the delivery chain from the RDC to the store for very obvious reasons. We do some long-distance store deliveries. So Tesco do a daily train from central Scotland to Inverness, where swap bodies are then delivered to the store, and we probably will end up doing fairly soon something similar down in Cornwall. But we're now starting work on some really interesting stuff about urban deliveries into London, and that will probably be based on small containers, probably 20, 30 foot for the high street, and really innovatively, van bodies, intermodal van bodies for home delivery, where you pick once at a central DC and it goes right through to your door without being touched immediately, which takes huge cost out of the supply chain. I'll leave it there in terms of terminals. Major manufacturing plants are also an important thing. That's fairly self-evident. So there we go. I won't run through the conclusions that are there. I'm assuming you're going to make the slides available to everyone. You're very welcome to if anybody wants them. And happy to answer any questions you might have later. Thank you.
Thank you, Julian.